Welcome to our session on substitution reactions. Now, the nice thing about substitution reactions is they're similar, well, they're not similar to addition or elimination, but with elimination and addition, we were looking at the difference as changing between a saturated and unsaturated compound. In substitution reactions, we are only going to be looking at saturated compounds where we literally substitute, all right? So it makes it nice and easy. So we are going to replace or substitute an atom or a group of atoms with another atom or a group of atoms, all right? So the general reaction being that I have a hydrocarbon, I add a compound to it, we're going to look at the different types, and those two atoms come off and they get replaced by the two in the compound that we're looking at. So it really is exactly what it says. It is a substitution reaction where we are replacing one atom with another. So first thing we're going to look at is the interconversion between alcohols and haloalkynes. The thing about this interconversion means that we can separate, we can switch between the two. So we can go from an alcohol to a haloalkane if we react it with a hydrogen halide or a halogen. We can go from a haloalkane to an alcohol where we reacted with a hydroxide. Now please be careful with what we call these, okay? It's a type of hydration. So let's look at how we get alcohols to become haloalkanes. Haloalkanes simply means the first way we do this is we take the alcohol and we react it with a hydrogen halide. Okay, HX, remember X can be bromine, chlorine, fluorine, or iodine, all right? So we're using the haloalkane and we're going to react it with whatever the alcohol is. Now, the thing here we have to remember is the conditions. Tertiary alcohols only need to take place at room temperature. It's actually quite easy to convert them, whereas your primary alcohols, we need to heat them up, okay? We need to add extra heat to them. First example, the reaction between CCH3 OH HBr. Now, here, they've given us the condensed structural formula, and what's really important is we need to draw it out, because that's the easiest way to draw this, okay? Because if I was just simply doing it as a reaction where we want to look at what we get left with, the point here is we're going to get water, so I know the OH comes off, the HBr comes off, and the OH and the Br will change space. But let's look at what it would look like. CCH3, so they're telling us I have a carbon. Attached to that carbon, I have 3 CH3 molecules. And then I have the OH. Alright, so they gave us the condensed structural formula. This is a tertiary alcohol. This would happen at room temperature, nice and easy. We're then going to get HBr. What's going to happen here is the OH is going to come off. It's going to swap with the Br. Okay, so we're going to end up with a haloalkane and we're going to end up with water. The first part of this, okay, so let's just do this. I want to make sure I've got enough space. You guys would do this all in one straight line. I'm writing too big for that to happen. So the CH3, that's not going to change. All right. That's going to stay the same. That is what it is. We're not going to be able to change any of that. But what we are going to do is we're going to replace the OH with the Br. Then no, it's not going to become an arrow. That's just silly. It's going to be a plus. What we're going to end up doing here is then we're left with water. All right, and in the naming, wherever the alcohol is, that's where the Br was. So if we go and name this, the first one here, we would have had, this is 2-methyl propan 2-ol. All right, we now have 2 bromo 2 methyl propane. All right, let's look at one that's a little bit different. So now this isn't a tertiary, this is a secondary alcohol. We now have the reaction between butane 2-ol and HCl. They're telling us it's at high temperatures, giving us the conditions to make sure we know it can happen. Starting with the butane 2-ol, so butane 4, 2-ol, that means we have the OH on the second carbon. Alright, we have the OH on the second carbon. We're going to add HCl to it. And all that's going to happen, that OH is going to come off and be replaced by the chlorine, which means we then end up with 2-chlorobutane. So we have 1, 2, 3, 4. The chlorine's going to go on the second one. We don't forget all the hydrogens. Alright, there we go. And we will then end up with water. Okay, so we had butane 2-ol, and now we have 2-chlorobutane. Straightforward, nothing too difficult, okay? Excellent. Now, here they give us, write an equation for the reaction between C2H5OH and HCl. Also show the reaction using structural formulae. Now, the first part of this is just writing the equation. They don't want anything exciting. They're not asking you to do it in any other form than to write it out in the same format they gave it to you. So we had C2H5OH. We're going to react it with HCl. We are going to end up getting C2H5Cl H2O. Now, they did say at room temperature, but this is a secondary, well, it's a primary alcohol, which actually means we really should have done this at increase the temperature. All right. Now they also want this as a structural formula. So C2 means C2H5. There's 3 of them. There's the OH. All right. What does that give us? It doesn't actually matter where you would have put the OH because it's going to, it's the same thing wherever you put it in this case. All right. So that leaves us with chloroethane, sorry. There's the Cl, there's the H2O. Very straightforward. Now, when we take a haloalkane and we convert it into an alcohol, it's called hydrolysis. It's not hydration, it's hydrolysis. Reacting it with a hydroxide, we're going to get a salt and we're going to get the alcohol, so we don't end up with water at the end, okay? We have to have a strong base. This is really, really important. Now, the conditions here, compared to when we have an elimination reaction, the conditions are really important. It's a dilute strong base. For an elimination reaction, it's concentrated. This is a very, very important part of this. We also need to heat it, not as much as we do with an elimination reaction, but we still do need to heat it. We dissolve it in ethanol just to help the reaction. Okay, so they give us 2-chloropropane. So we need to draw it. So chloropropane, start at the back. Propane, 1, 2, 3. On the second chlorine is the OH. There we go. And we are reacting it with the NaOH. Okay, so it's part of the reaction. I know that chlorine's going to come off. It's going to bond with the Na. So in other words, I'm going to end up with NaCl. no choice as to where the OH goes. It's just going to replace the OH, the Cl. All right, so we end up with, probably should have drawn that going down, but it doesn't actually matter. So we had 2-chloropropane. We now have propan 2-ol. Where the chlorine was, the alcohol goes. Straightforward. Okay, look at another one. Similar to what we had earlier in terms of the methyl group, this is a tertiary. All right, so when we look at it, we've got CH3. There's the one. There's the second one. Okay, let's just make sure we keep all the hydrogens in. We can't lose those. Oops, I hope you can see that one. And there's the Br. All right, we're going to add it to potassium hydroxide. The potassium and the bromine will go together. That's going to give us potassium bromide. And then we're going to end up with a tertiary alcohol. Okay, so the C with the CH3s, that's not going to change. That's where it was. Oh, oopsie. Let's take that out. There we go. CH3, don't forget the methyl group. And then we have the OH. All right, straightforward. Okay, the thing to remember here is the halogen comes off, gets replaced with the OH. The halogen then bonds to whatever the OH was bonded to. Okay. What about haloalkanes from alkanes? So now you've actually seen this in a very, very quick way when we looked at the test of saturation. Hydrogen atoms in the alkane will be replaced one at a time by the halogen atom. Okay, so if we look at the reaction between methane and chlorine, so we'll start with an easy one. Methane, CH, there's all my H's. Remember, chlorine is diatomic. Now, what happens here is only one hydrogen will get replaced. So the first time we do it, we only end up with one. Then we end up with HCl. Now, obviously, it makes absolutely no difference which hydrogen comes off, but one of them would come off. So what we've now got is chloromethane. If we let this reaction keep going, so I don't stop the reaction, but I let it go, what will happen over time is this chloromethane will now react with chlorine again. Okay, so we've still got the chlorine in the reaction. All right, so this becomes here. This will now become dichloromethane. Okay, and we will still have HCl. We can react that again. Okay, so we can do this again. So we take that, we react it with Cl2. Now we're going to have 3 chlorines attached to it. Trichloromethane, which you actually do know as chloroform. And eventually, if I let it react long enough, all right, so I just let it keep going. If this now reacts with chlorine again, that probably to do that, what we'll end up with is tetrachloromethane, which is something you've actually seen before. And tetrachloromethane, you also know as carbon tetrachloride, CCl4. It's a very good solvent. Okay, we use it for a lot of things. But don't get stressed about it. If I ask you to do a reaction like this, I only need you to do one at a time. Okay, one at a time. So, if we look at the reaction between ethane, and bromine, so ethane we can draw quite easily, ethane. All right, there we go. And we're going to react it with bromine, right? So what does that mean? Well, one of the hydrogens will come off, going to create bromoethane and hydrogen bromine. Now, for alkanes, where more than 2 carbons in its chain, the halogen can be substituted in different places, so we get isomers. Okay, now please remember that with isomers, all right, the point here is that we will get a major product and a minor product. We will always expect you to do the major product. So how are we going to know what that major product will be? Well, it's fairly straightforward. So if we look at propane, 1, 2, 3, propane, with chlorine. Okay, so we have choices here. Either one of the middle hydrogens are going to come off, or one of the end carbons. Now this is the same as when we were doing the elimination reactions, in that the hydrogens that bonded to carbons with lots of hydrogens already, they're not going to come off. So in reality, we will get more of the one where the hydrogen from the middle carbon will come off. So in other words, what we would create here is my major product would be 2-chloropropane. This would be my major product, because my last carbon still has lots, so this is my major product. However, I could also get very easily 1-chloropropane. That's my minor product. With both of these, I still end up with HCl, okay? So please don't stress about that. But that's the same rule to know what our major product would be that we would have used when we looked at elimination reactions, okay? Hopefully that makes sense. If necessary, watch it again, and we'll chat soon.